Hello. In this video, we're going to look at how to factor complex trinomials using a method called decomposition. So this first example, we want to factor 2x squared minus 5x minus 12. And the first thing we notice is that the other factoring methods that we've covered so far aren't going to apply here. So for example, the three terms that are in this trinomial don't have a common factor. So common factoring won't get us anywhere. Also, this is not a difference of squares. And this is not a simple trinomial because a simple trinomial only has a coefficient of 1 in front of the x squared term. And this trinomial has a coefficient of 2 in front of the x squared term. So this is what we call a complex trinomial, where the coefficient of x squared is something other than 1. And we have a trinomial in the form ax squared plus bx plus c, again, where that coefficient of x squared, so a is a number other than 1. So the method of decomposition goes as follows. The first thing we're going to do is we're going to look for two numbers that multiply to equal not just negative 12, but negative 12 times this 2. So negative 12 times 2 is negative 24. So we want two numbers that will multiply to negative 24, and those same two numbers need to add to give this middle term negative 5. Okay? So in this case, those two numbers are the numbers negative 8 and 3. Right? Negative 8 times 3 is negative 24, and negative 8 plus 3 is negative 5. So we're going to use these two numbers, negative 8 and 3, in order to break up this middle term of negative 5x. That's where the decomposition method comes in. So decompose or decomposition means to break something up. So we're going to break apart this middle term into negative 8x and a positive 3x, because combined, those make negative 5x. So again, we start with 2x squared minus 5x minus 12, and we're going to replace the middle term with negative 8x plus 3x. So those come from the two numbers that we found up here. So instead of negative 5x, we now have negative 8x plus 3x, which is equivalent. Okay. The next thing we're going to do is we're going to common factor, but we're going to common factor in pairs. So we're going to look for a common factor from the first two terms, and then we're going to look for a common factor from the last two terms. Okay. So the common factor from the first two terms is a 2x, and that leaves us with x minus 4. Okay. And the common factor from the last two terms, 3x and 12, I can take out a common factor of 3, and I'm left with x minus 4 again, because 3 times x is 3x, and 3 times negative 4 is negative 12. Okay. Now we're going to common factor again. So I see here I have one term here and one term here, and both terms have an x minus 4 in them. So I'm going to take out that x minus 4 as a common factor. So I'm going to write it in front. Okay. Now, from the first term, if I take out the x minus 4 as a common factor, what I'm left with from that first term is a 2x. Or in other words, 2x times x minus 4 divided by the common factor of x minus 4 leaves me with 2x. Same thing from the second term here. If I divide the second term by x minus 4, I'm left with a positive 3. This is our fully factored form. X minus 4 times 2x plus 3. Okay, perhaps you might want to pause the video at this point and you could try this factoring question and join me back here for the solution. Okay, so we are going to use the same method of decomposition. So here we want to find two numbers that multiply to give 3 times -2. So we want two numbers that will multiply to -6. Those same two numbers should add to +5. Okay, so those two numbers are 6 and -1 multiply to -6, and 6 and -1 add to 5. So we have that 3x squared plus 5x minus 2 is equal to, we're going to split apart that middle term of 5x by replacing it using the numbers that we just found. So we're going to replace that with plus 6x minus 1x. Okay, now we're going to common factor out of the first two terms and then common factor out of the last two terms. So the common factor in the first two terms is 3x, and that leaves me with an x plus 2. And the only common factor I can see here is because that first term here in the last two terms, because that first one is a negative value, I can take out a -1. But other than a 1, there's no other common factor between 1 and 2. So we take out a -1, and then we're left with an x, and -1 times +2 would give me the -2 from here. Okay. So if you're using decomposition, you always want, when you get to this step, you always want there to be a matching binomial here. So in this case, the matching binomial is x plus 2. And that matching binomial means that I can take out that matching binomial as a common factor between these two remaining terms. Okay, so if I take out x plus 2 as a common factor, from the first term, I'm left with 3x. And from the second term, I'm left with a -1. And so again, this is our fully factored form. Remember that you can always check your factored form by expanding. And if you expand this, then you should end up with 3x squared plus 5x minus 2.